Hello, guys, ladies and gentlemen. How are you doing today? I hope you're doing fine because today I bring another video doing programming because I started a series a while ago on Arduino programming, and I've been doing it for a while, and I find it very, very interesting. So, you know, I'd like to bring everybody on board. Yeah, I believe it's a very good tool that anybody can use to do all kinds of cool stuff, man. And it's the future as well. So today we are going to look at the programming part of it because we're supposed to start it, and so today we look at how to program Arduino. But before we get there, in case you've never done programming before, so what exactly is programming? I mean, imagine a kid asking you what exactly is a programming. I mean, a layman, a guy who don't know, who doesn't know what exactly is programming. So what is it? No? Okay, there is a simple definition of it, like it's a way of giving computers instructions, and then computer does what you give the instructions, follows the instructions you've given it, and then it does something, right? I mean, you can only go so far with that definition. Okay, that's what really happens, but um, when it comes to like understanding it, yeah, what really is it? What really is programming? So, according to my understanding, is my philosophy of programming. With programming, with everybody in this world is programming something. That's what I know. Okay, anybody in this world is programming something. Okay, that's our nature. That's what we do constantly every day. Okay, for example, when you're um when you're building a house, normally the civil engineers are the ones who are building the house, right? So they are building the house for the users who are going to rent it or buy it or live in it. Okay, then in this house they are going to lay down the foundation. They're going to and then they know how to do it. It's their way. It's a specific way of doing things. Like a foundation, you do this, you do that. Okay, you're with floors, when laying down concrete, when laying down cement, you're doing this, you do that. So we are building a house constantly. So for example, with foundation, you have to dig a you know there's a way. Of course, different communities do it differently, but no, at least from where I'm from, there's a ditch that's being dug after a house, and then you pile down stones in there, and then to make the foundation strong. See, those are specific instructions. Okay, it's like we are given instructions. For my philosophy, at least, we are giving instructions to nature. Okay, we are trying to create this thing, but in a natural environment. Okay, if you compare that to computer, we are trying to create this thing in a computer environment, which is a virtual environment. Okay, so in nature we are building it, we are building houses, we are building cars, and then these cars, there's a it's like the way the door is put, the way the windows are put, there's a specific code, there's a specific instruction that it's being followed. The way the windows, the doors, the floor, that's basically programming. If you translate that to programming, they lay down code. There's a specific instructions you have to follow. If you don't follow them, the compiler is gonna scream at you. I mean, you ain't gonna go nowhere. Compare that to building. If you are laying out window in the wrong way, probably it's gonna uh, fall out, or the wall might crumble in and kill people. With programming as well, if you write down the wrong instruction, that's you're not following the way it's supposed to be done, the code will crash. And if it's a critical system like an airplane, that's what's gonna happen. Like for example, the Boeing, uh, yeah, that plane that kept crashing down, it had a software problem. because there was some problem with algorithm and stuff. But if you do something wrong, it's gonna crash. If you do something wrong when building a house, it's going to fall in and kill people. There are different houses that kill people. That's how programs crash, and airplanes kill people. So there's a specific instruction that you follow when you're building a house. There's a specific instruction that you follow when you're building a when you're writing a code. Okay, it's like you're building, but in a computerized environment, in a virtual environment. Okay, another example is, and then another example, like when you're building a car, I mean, you have to use this type of material. It has to be aerodynamic. The design must capture whatever is in the market right now. So it has to have some headlights, have like some brake lights. That's how you do. That's what we do with code as well. The code has to have a user interface that the user can interact. The car's user interface, the dashboard. You're interacting with the car through the dashboard. You have to build all that, the steering, the brakes, how to control the engine and stuff. And then with computer, the program itself, you can imagine it like it's the engine or something. Then you have to control it through the buttons and all that. That's at least my philosophy, because everybody's building something. I mean, there's no way we can create something new out of. I mean, it's something that's been there, but it's in a computer environment. Okay, so with programming, since you know that we are basically building things but in a computer environment, and there are some set of rules that you need to follow, or whatever you're building is not gonna come out fine. Okay, there are some specific set of rules that you have to follow. Okay, so with these rules, there's a way they're divided. There are some features that comes in. Everything comes with this set of rules. You have to understand a bunch of other things so that you can know what these rules are being applied. Okay, so for instance, I normally use there's these guys tutorial points. They have a lot of tutorials, and they are very good tutorials. So if you look at Arduino here, we are programming the microcontroller and what is inside the microcontroller. You can check right now. So features of microcontroller. Okay. So what I tend to think, it's like, if you can see this, yeah, this is it. Block diagram of microcontroller. There's something called, for the program to work, okay, for the program to run the way it needs to be and to do whatever you want it to do, there's some features that it must have. Okay, the arithmetic logic unit, the RAM, the ROM, the stack pointer, program counter, registers, clock circuit, interrupt circuit, all these things. Okay, this is an 8051 microcontroller. If you watched the previous video, we discussed different microcontroller types, and then this is an 8051 microcontroller. You can check another microcontroller type is to make 328 microcontroller. Okay, so this is the microcontroller that's running on Arduino Uno. Yeah, and it's running, the Arduino code runs in it, and whatever it is done. So like I've just said, these are the bunch of features that are available in any microcontroller. Okay, this diagram describes it quickly. So you see that there's an interrupt control, ROM, RAM. So in case you don't know what these are, ROM is like an hard disk. The storage location, it's probably 4K, 4 kilobytes. Okay, RAM is when the when the processor, which is just the computer, is processing instructions. This is the CPU. You are giving it instructions from the code that you're giving it, and then they have to be stored somewhere temporarily so that they can be processed, and then the output is being experienced in the device you're trying to control. So the CPU crunches the numbers, but with the help of RAM, okay? It's temporarily stored. So let's say you want to add, like, you want the microcontroller to be able to add, like in mathematics, wanted to add like 1 plus 1. 1 has to be stored somewhere temporarily. Then the other one as well has to be stored somewhere else temporarily so that they can exist inside that microcontroller, okay? They have to exist there first. And then the CPU will add 1 on top of another one, and then the result also has to be stored somewhere temporarily, because if there isn't anywhere the result is going to exist, I mean, there's no way you can get it. So it has to be stored there temporarily, and then you're gonna, decide whether you want to store it permanently then in the ROM, okay? Yeah, that's what RAM, even in computers like the one that we use, like Intel things, laptops, the RAM, that's why you find that if you have like a less RAM, the processing power of that computer, the computer just becomes slow. Yeah, slow, 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 and then yeah, you can't do anything. Just open, let's say, a browser, and boom, it goes away. It just freezes because the RAM is just getting full all the time. Operating system needs, everything needs RAM. It's such an important component. And then the CPU is the logic. I mean, it is what understand what's going on, the logic, weighing things out, comparing numbers. Like, you might ask yourself, how does a microcontroller know if 1 is less than 2, okay, or if 2 is greater than 1? See, that kind of common sense thing, that's the CPU. It does that. It weighs out numbers, okay. And then the next thing we're gonna look at is this one, OSC. This is the oscillator. Yeah, this is the oscillator. What it does, it generates pulses, okay. Yeah, so in case you don't know what these are, pulses, what is a pulse? That's a different type of yeah, sorry. So let's Google digital pulse. See this? Yeah, that's a pulse. I don't know if a lot of people know what this is, but in case you don't know, I'll try and explain, okay? So in computing, at the core of everything, it's just electrical signals, okay? Just an electrical signal. So okay, this is a rabbit hole. This is some kind of rabbit hole. I'm going to get into deep. Okay, what are transistors? Okay, what are transistors? In case you don't know what a transistor is, it's just a device that can, it's basically like a switch. It can switch on and off, switch on and off. So for this microcontroller to work, it has to get some pulses, okay, from the so that the data can flow. For the data to come from one point to the next, it has to flow through electrical signals, and these electrical signals come in form of pulses. So this one is this oscillator or crystal is the one responsible for generating all these pulses. That's how it's just like a medium of data transport, okay. Yeah, it seems like I'll have to explain what exactly pulse is in a separate video, but at this point, just know that for example, in Earth, okay, for us to exist, for you to communicate with another, you have these for sound to travel from one point to the next, it has to pass through air. I mean, in a vacuum, you cannot hear what anybody's, because sound propagates through mediums, right? According to physics, yeah, sound has to propagate through a medium so that you can hear, okay. Even so, in a microcontroller environment, all these instructions coming from CPU to RAM to all these things, they have to go through a medium. They're just a bunch of wires connected together, but then the electrical signal, the electrical pulse, it's what's going through this oscilloscope. It's just like the heart. Yeah, it's the best analogy. In human beings, the heart, you know, the cardio, the the cardiovascular system is the one responsible for pumping blood through the body. Okay, so in an oscillator, just like an alive being. Okay, so oscillator supposed to generate all these pulses, and then the pulses move across all these components. Okay, so it beats up, or the signals come in certain frequencies. Mostly is 56 or something. Yeah, let's check in Arduino. It's 16 megahertz. Yeah, that's what I know. Yeah, I told you it's 16 megahertz. So let's look at the hertz. Average frequency. Yeah, 0.6 to 2 hertz. I mean, of course, the heart goes way slower, 2 hertz, okay. But with Arduino, it's much faster. That's how it's able to process all these things. So this 16 megahertz is like the heart's pulse, it generates pulse, and that's how the signals are able to, to move from one component to the next. That's why the crystal determines how fast a microcontroller is. Okay, yeah. So basically that's how it is. Then the next part is the bus control. Yeah, this is what's responsible for the community. It's like just like a traffic police, man. Okay, for all these things. And then the IO ports, which are the address pins and the digital pins. For those who don't know, Arduino has digital pins as well as address pins. You go check out the previous video that I uploaded. Okay, yeah, you're gonna see all this address. So this is how you connect peripherals to this microcontroller. So when you want to connect another sensor to this, because the only peripherals you can connect, there are a bunch of sensors, so you have to connect them to the microcontroller and through all these IO ports, input and output ports. So these are where you connect all the peripherals, and the serial port as well. This is the main transmission protocol that Arduino uses. So it's called UART. We also discuss we will discuss the transmission protocols. In case you've done networking, there are things called UDP, TCP, those networking protocols. So within electronics as well, it's basically networking, but they're different. This one is serial, which is UART. There's one called SPI, serial peripheral interface. There's one called I2C, and yeah, basically those ones. I don't know if I'm forgetting one, but yeah, there are those ones. So yeah, so this is the internals of an Arduino microcontroller or any other microcontroller. It's basically like even a computer has all these things. It's just like a tiny computer that's capable of doing a bunch of stuff. Yeah. So I hope you've understood. I don't want to make this video too long. I hope you've understood the internals of a microcontroller, and also the philosophy of programming. Okay, so in the next tutorial we're gonna fire up the IDE and try a bunch of stuff up, right? How's that sound? So in case you have any questions, because my philosophy is different the way I teach, because I believe this is the best way to teach. So I just tell you what's in there. You have to understand what's going on, like at a deeper level. I mean, you can just jump straight into code, but if you don't really know what's going on, there's challenges you can't really solve, and you cannot think your way out of it, so you have to understand what's really going on. So I don't want to take much of your time, so have a good day. Think about it, and on your free time you can check out this site, Tutorials Point. I'm gonna leave the link in the description. Meantime, subscribe, like, share, comment, like, anything, and any engagement. Yeah, great. So we're going until we meet next time.